but let's begin. So Cramer's rule is just another way to solve a system of equations, right? So you guys know how to do it by elimination, substitution, even graphing is an acceptable method. This is just another way to solve systems, and it's just by using a bunch of determinants. So a couple of days ago, we learned what a determinant is. By using determinants of these matrices, we can get our answers for x and y. So one thing that I like to do first is with our coefficient matrix, we're going to have an x column and a y column, and those are just the coefficients of the x's and then the coefficients of the y's. We first start by finding the determinant of the coefficient matrix, and then afterwards we find two more determinants, right? We have to find the determinant with this little sub x here. All that is we're going to take whatever our system is equal to, and you're going to replace the x column with those numbers and leaving y the same. Same thing with d sub y, right? We have something like this where we take those same numbers, 3, 8, and we replace them with the y column. And your final answer that you guys are familiar with is always going to be x comma y. To get your answer from these, it's going to be dx over d, comma dy over d. All right, so it might seem confusing at first. We'll do some examples. All right, I want you guys to start by solving this however you know how. Substitution, elimination, whatever it may be. So just take a second, solve it, get an answer. And then I'll show you how to do it using Cramer's rule. Okay, so you guys got 2 comma negative 1 as your answer. Okay, cool. So that's how you did it. Substitution, elimination, however you did it is fine, right? That is the answer. I'll show you how to do it using Cramer's rule. First, I'm going to set up the columns. So we're going to have an x, y, and then whatever it's equal to. What are the coefficients of x? 4 and 3. What are the coefficients of y? Okay, I'm going to keep the sign with it, -2, -5. And then what are these equations equal to? Good, 10 and 11. I'm going to first start by finding the determinant of the coefficient matrix, which is just a capital D. And it's going to be the determinant of whatever numbers are in our coefficient columns. So 4, 3, -2, -5. All right, so let's find this determinant. Do you remember how to do that? The diagonals, right? So it's going to be 4 times -5 minus the other diagonal, 3 times -2. So then we should get -20 minus -6 is +6, and so we should get -14. All right, so this is capital D. All right, now I'm going to find dx. And to do that, you're still going to find a determinant. You're just going to replace the x column with the numbers, right? The numbers that it's equal to, so 10 and 11. And then we're going to have a -2 and a -5 as normal. All right, so find that determinant. Let me know what you get. Oh, with the x, these 4 and 3 originally belong to the x. And so you're replacing the x column with this one. The y's you're keeping the same. Okay, good. So we should get this diagonal, 10 times -5 is -50, minus this diagonal is -22, so plus 22 should get you, yeah, right, -28. And then so that gets us dx, bless you, is -28. All right, we'll do the same thing with y. All right, so let's do dy. Our x column is going to be the same now, 4, 3. And then you're going to replace the y column with the numbers now, so 10 and 11. Same exact thing, you're going to find some determinants or find the determinant of this. 4 times 11 is 44. Good, right? So then minus 10 times 3 is 30. And so we get 14. That means dy is 14. And so to get your answer, we have that x is going to be dx over d. So let's find that. Negative 28 over negative 14. What does that get you? Good, 2. And then y is going to be dy over d. So 14 over negative 14, which gets you negative 1. So that means your answer is 2 comma negative 1. All right, and isn't that exactly what we found earlier? Yeah, right? So just another way to solve systems. Okay, so there are 2 more examples here. There are 3 variables now. All right, it'll be the same exact process though. All right, so you first want to set up your columns. This time it'll be an x, y, and z column, and then you'll have another numbers, right? So what are the coefficients of x from top to bottom? Good, right? If we don't see an x, you assume it's 0. So negative 1, 2, and 0. And then what about the y's? Good. And then z's? Nice. And then the numbers that they equal are a 4, negative 3, and 1. All right, now let's find d. This time, this is the determinant of a 3 by 3 matrix. So this is the only time where this lesson can get a little tricky. You just have to be careful with your work. We learned how to do this a couple of days ago. What method do you guys prefer? Okay, the one with the other 2 columns, right? Okay, good. I figured most people prefer that one. So, yeah, okay, that's fine. So then I'm going to take these 2 columns, and I'm going to rewrite them on the outside. Yeah, I figured most people prefer this one, right? And then you want to find the determinant of this by using the diagonals. All right, so we're going to go along the major diagonals. So we're going to do negative 1 times negative 1 times negative 3. What does that get you? Good, negative 3. Same thing with the next one. 0 times 1 times 0. 0. And then same thing with the next one. 1 times 2 times 1. Good. And then this is all going to be minus the minor diagonals. So 0 times negative 1 times 1. Good, so 0. And then the next one is going to be 1 times negative 1. Negative 1, good. And then negative 3 times 2 times 0. 0, right? And then you just simplify this as much as you can. This here is going to get us a negative 1. Minus, this is going to get us a negative 1. So what is this now? Okay, so we get a 0. No, right? Why do we think? Right? Because how do you get your x value, let's say? Dx over d, which is going to be a number, whatever that is, over 0. Can you ever do that? No, so what do we say about this system? No solution. This system does not have an answer. All right, so that's what a no solution would look like using Cramer's rule. If you had done it by hand, you would get the same answer. Okay, so now let's give this one a try. Same exact thing, I'm going to set up the columns, x, y, z with the number, and then we're going to pull those numbers to get our determinants. So negative 1, 2, and 3. In the y column, we have a 2, a 0, and a negative 4. In the z's, we have a negative 3, a 1, and a 4. Our numbers, we're going to have a 1, a 0, and a 2. All right, so let's start by finding the determinant of our coefficient matrix. So I'm going to take -1, 2, and 3, 2, 0, and 4, -3, 1, and 4. All right, and we want to find this determinant using the method that you guys like. I'm going to take those two columns and I'm going to rewrite them on the outside. So -1, 2, and 3, 2, 0, and 4.
Why don't you use the number?
All right, so now let's find this. Same exact way that we did before, so I'm going to go across the major diagonals. And then I'm going to find that number. We're going to do -1 times 0 times 4 is 0. Plus 2 times 1 times 3 gets you 6. And then -3 times 2 times 4 should get you -24. All right, and then we're going to do that minus the other diagonals, all right, the minor ones. So we're going to go in this direction now. 3 times 0 times -3 is 0. Plus 4 times 1 times -1 is -4. Plus 4 times 2 times 2 should get you 16. Right. Oh, you're right. Sorry. -4. Okay, so that's plus. Sorry. Let me get rid of that. Oh my goodness. Okay, yeah, that's right. Sorry. -4. Okay. Plus 24. Is it still plus 16?
Yes.
Yeah, right? 4 times. Okay. That's fine. Okay. Nice. Okay, sorry about that. 30 minus, and then 4 plus 16 is 20. So 10. All right, so then capital D is 10. Bless you. And then we have to do this 3 more times to get X, Y, and Z, right? So this is about as tedious as these get, right? It's not particularly difficult, it's just very time consuming. All right, so dx, we're going to replace the x column with our numbers. Our numbers here are a 1, 0, and a 2. So 1, 0, and 2. Everything else stays the same. 2, 0, -4, -3, 1, and 4. And then once again, we're going to copy our 2 columns. So 1, 0, 2, 2, 0, and -4. And then you're going to find these determinants, or this determinant, right? So we're going to do 1 times 0 times 4, which is going to get you 0. 2 times 1 times 2, which is going to get you 4. And -3 times 0 times -4, which is 0. And then minus the other diagonals, right? So we're going to do 2 times 0 times -3, which is 0. -4 times 1, which is going to get you -4. And then 4 times 0 times 2, so 0. And then you end up with 4 plus 4, which is 8. So that means dx, we get 8. Now let's try this again with the y's. So dy is going to be, okay, -1, 2, and 3 are going to stay the same. Now we replace the y column with a 1, a 0, and a 2. And then you keep the z column the same, -3, 1, and 4. And then once again, copy your 2 columns on the side to get this determinant. And then we're going to do the same process. Major diagonals, find the product. What do we get here? What plus what plus what? Okay, good. So we get 0 plus 3 plus -12, so -12. Good. And then we're going to do minus the same thing on the other side. All right, we're going to do our other diagonals. We're going to do 3 times 0 times -3 plus 2 times 1 times -1 plus 4 times 2 times 1. So it's going to be what plus what plus what? It's another 0, right? Minus 2 plus 8, right? Good, all right, and then so we should get negative 9 minus 6, bless you, so we get negative 15, good. And then that's dy. So dy is negative 15. Okay, we're almost done with this one. And then the last one is going to be dz. So it's going to be negative 1, 2, and 3. What was it? 2, 0, negative 4. And then 1, 0, 2 now replaces the z. And then we're going to take the original first two columns, rewrite them on the outside. And then do your major diagonals. And then the minor ones. All right, so in green, our major diagonals, negative 1 times 0 times 2 is 0, plus 2 times 0 times 3 is 0, and then 1 times 2 times negative 4 is negative 8. Minus, we'll do the same thing across the yellow diagonals, so we get 0 plus 8. And then we end up with negative 8 minus 8, which is negative 16. So we get dz is negative 16. Okay, so we're almost done. Now to get our x, y, and z's is we're going to put all of these numbers on top of each other. So x is dx over d. Y is dy over d. And then z is dz over d. All right, the original coefficient determinant that we found was 10, so everything's going to go over 10. So x is going to be 8 over 10, so 4/5. Y is going to be negative 15 over 10, so negative 3/2. And then dz is going to be negative 16 over 10, so negative 8 over 5. So then your final answer as an x, y, z ordered triple is going to be 4/5, negative 3/2, and negative 8 over 5. All right, so it's not the fastest thing in the world, but 3 variables usually are not super quick anyways. Yeah, right, the original D was just the coefficients. I didn't replace anything with this right here. All right, so it was just the x, y, and z coefficients. All right, but that's it. That's Cramer's rule. Just another way to solve systems. I do believe on the quiz we give you 1 Cramer's rule. So you need to solve specifically using Cramer's rule.
I don't understand.
It's just, okay, so you need to think of these columns not as just columns of numbers, but they represent something here, right? Everything up until now, up until this lesson, we've just been doing matrix operations, finding inverses, finding determinants, just multiplying, all that. These numbers mean something here. So this column, this column isn't just a number of negative 1, 2, and 3. These are specifically the coefficients of x. Same thing with these numbers here. These numbers are specifically coefficients of y. They're not just random numbers. We didn't get them out of nowhere. So if you're solving for x, you're replacing this x column with these numbers here. If you're solving for y, you're replacing these original numbers here with that column here. If you're solving for z, you're replacing this original z column with that number here. Everything is based on your coefficient matrix. And what you're solving for is just going to depend on where you're going to put this column right here.